Things you might not know about resistors. Resistors, as you might know, is one of the basic components of an electronic circuit. And as the name suggests, it resists or limits the flow of current. There are two symbols of a fixed resistor. In North America, they use this symbol, but in Europe or other countries, they use this symbol. In our country though, we use this. You might know this resistor color code for identifying the value of resistors. In our country, we are taught using these mnemonics. Bad boys rape our young girls, but Violeta gives willingly. But if you see an SMD resistor like this, it's the same idea with the color code, but it's much easier. No need to memorize the code because it's directly printed digit. The last digit tells us the number of zeros to be added. If you see the letter R, just imagine that it is a point, so this will be a 9.0 ohm resistor. But oddly, some resistors though just directly marks the exact value, like this 39 ohms 7 watts, and that is the power rating. So resistors have a power rating or wattage rating, so when you use a resistor, be careful not to exceed its power rating. This will happen when you overpower a resistor. This happens because the heat produced is too much for it to handle, so a high wattage resistor is needed. High wattage resistors are often big and can be mounted on a heatsink. Using these formulas, you can calculate the power dissipated on a resistor. Speaking of power rating, you can add the power rating of the resistor if you connect them in series or parallel, but commonly you will connect resistors in parallel that has a similar resistance. This will add their power rating. Connecting resistors in parallel will decrease the total resistance. Using this formula will determine the total resistance. So if I connect these two 15K in parallel, using this formula will result to a 7.5K resistor. You can connect resistors in series to add the resistance. So for example, if you need a 30K ohm resistor, you can just connect two 15K ohm resistors, and there you have it. Resistors are also useful in dividing voltages. For example, you have two resistors connected like this to a 5V source. The voltage on the middle will be divided. You can use this formula if you want to calculate the voltage. You will be amazed in the future how useful is a voltage divider. You can find voltage divider in a lot of circuit design. There's also a resistor that you can vary the resistance. They are called variable resistors, or we can call them potentiometers. Commonly, they have 3 terminals. You can connect these terminals to a supply. Now it functions like a voltage divider, but instead its output will change when you turn the knob. So you can see potentiometers on sound amplifiers to adjust the volume. There's also another variant. Instead of turning, you will slide it. This is a light-dependent resistor, aka LDR, or sometimes called photoresistors. The resistance of this resistor is dependent on the light it receives, obviously. When we shine more light, the resistance decreases. So by connecting another resistor like a voltage divider, we now have a changing voltage with respect to the light. Basically, now we have a light sensor. There are also resistors which are dependent on the temperature. They are called thermistors. Obviously, this is salvaged from a thermometer. This one looks a bit different, but actually, it's also a thermistor, an NTC thermistor. There's also another type of resistor, which are called fusible resistor. As the name implies, it acts like a fuse. When something happens in a circuit, they will not burn and cause fire. Instead, they just fall open circuit because it's somewhat made of ceramic. Resistors are also built like this resistor. They are called array resistors. They are resistors with the same values made in a single package. They are useful and can save space and time during the manufacturing process. Lastly, we should remember that anything could theoretically act like a resistor. This piece of copper wire has a resistance. The thicker it is, the lower the resistance. Even the probes has a resistance. This PCB trace, the thicker the trace, the lower the resistance. This light bulb has a resistance, which also, by the way, is dependent of the filament temperature. The soldering iron has a resistance, that's why it heats up. And basically, all of the other electronics components has invisible resistor connected into it. And that's the things you might not know about resistors. If you learned something new today, please consider subscribing to my channel if you haven't already. And also hit that like button. This is pinoyEnginerd. Thanks for watching. See you later on my next videos.